Hey everyone, welcome to This Explainer. I am literally so thrilled you're here today because we're diving into something that absolutely blew my mind. We are talking about what is arguably the most critical infrastructure challenge in artificial intelligence right now. I mean, think about it. We have all these incredibly smart AI agents being built across different companies and platforms. But how do they actually connect? How do they find each other, trust each other, and communicate securely? Well, today, we're looking at the architecture that makes this all possible. Specifically, we're looking at bridging Agentic Resource Discovery, or ARD, with the Agent Transfer Protocol, AGTP. Okay, let's dive into this. Here is our roadmap for today. First, the agent discovery breakthrough. Second, the hidden HTTP problem. Third, enter Agent Transfer Protocol. Fourth, how ARD and AGTP compose. And finally, number 5, the next infrastructure decision. We are going to build our understanding layer by layer. Right, so kicking things off with Section 1, the agent discovery breakthrough and how tech giants solved agent discovery. To really appreciate this breakthrough, we have to start with a fundamental question. How do AI agents actually find each other in the wild? If an agent built by company A needs to book a flight using an agent built by company B, it desperately needs an ultra-modern, incredibly secure phone book. And honestly, until very recently, that phone book just didn't exist in any standardized way. Crazy, right? And this brilliantly illustrates the industry consensus on how to solve that. Just look at this list of heavy hitters backing the new Agentic Resource Discovery, or ARD specification. You've got Google, Microsoft, and Hugging Face as the actual authors, backed by absolute giants like AWS, Cisco, Databricks, NVIDIA, Salesforce, Snowflake. I mean, when this level of the tech industry agrees on a standard, you know for sure a massive shift is happening. They're completely united behind ARD as the solution. So what actually is ARD? Well, it's exactly what cross-organizational agent discovery has been missing. Think of it as a clean, federated, domain-anchored architecture. It basically acts as our highly structured phone book by publishing catalogs as simple JSON files at well-known paths. And crucially, it uses trust manifests that carry identities, things like SFIFI IDs, DIDs, XTIDE 509 certificates. Basically, these are ultra-secure digital passports. This means your agent can look up a capability and verify, hey, is this actually trustworthy, before doing literally anything else. But here is the absolute genius of ARD. It explicitly steps out of the way once that discovery phase is done. Discovery and runtime are fundamentally different concerns. ARD is just your directory. Once it helps you find the agent and verifies that trust, ARD deliberately hands off the actual connection, the runtime, the whole shebang, to whatever native protocol that agent uses, whether that's MCP, A2A, or OpenAPI. That handoff is the architecture's true elegance. But as we're about to see, that handoff also exposes a pretty massive problem. Which brings us to Section 2, the hidden HTTP problem. We are talking about the outdated infrastructure currently carrying modern AI. So the crucial point is that while ARD solved discovery beautifully, that runtime handoff reveals a glaring conflict. Notice the difference here. HTTP evolved for human web traffic, right? It was built for browsers, relying on virtual hosting, URL reconstruction, path-based middleware, all that stuff. But agent traffic? Entirely different beast. Agents require strict structural properties. They inherently need to declare their identity, their scope of authority, and their attribution on every single request. Forcing agent traffic through an HTTP pipe is literally like trying to fly a commercial jet using a steering wheel from a 1990 sedan. You end up having to bolt on all these critical security elements as flimsy, optional application conventions. And trying to force agent traffic through HTTP isn't just clunky, it has real, painful costs. Just look at the Starlette BadHost vulnerability that was disclosed back in May that affected thousands of agent deployments. Why? Simply because when you run agent infrastructure over HTTP, adversaries can forge, omit, or completely bypass application layer security conventions at the seams between HTTP's layers. The bottom line, HTTP just was not designed for the structural guarantees that autonomous agents absolutely require. Okay, moving to Section 3, enter Agent Transfer Protocol. This is the purpose-built connection specifically for agents. So if HTTP is essentially an outdated, unsecure party line, we need a private, dedicated fiber optic line. And that purpose-built line operates right here on port 4480. The Agent Transfer Protocol, or AGTP, defines a dedicated transport layer for agent traffic. It uses the IANA-registered port 4480 and operates under its very own distinct URI scheme, AGTP/. It completely detaches from all the old assumptions of HTTP. In a nutshell, AGTP is the answer to the substrate question. It doesn't sit around hoping an application chooses to honor some optional security header. No way. Instead, AGTP inherently bakes strict security properties directly into the physical wire connection. The agent's identity, the principal it represents, the claimed authority, and the structural attribution of who acted, all of that is foundational to the wire connection itself. Now, what's really interesting about this slide is how these 4 critical properties travel on every single AGTP request and response. First up, the canonical agent ID. That tells us exactly which specific agent is connecting. Second, the owner ID, which gives us the principal, the human or org, that the agent actually represents. Third, the authority scope, defining exactly what that agent is allowed to do. And fourth, the attribution records. This provides a JBS signed, meaning tamper-proof, audit-quality trail of actions. These aren't optional add-ons. They are wire-level facts. They absolutely cannot be stripped away or bypassed like a header in HTTP. Moving right along to Section 4, how ARD and AGTP compose. We are looking at perfect harmony across architectural layers here. So you might be thinking, okay, we've got ARD for discovery and AGTP for transport. Do they clash? Actually, no. The authors of ARD made this brilliant, incredibly generous architectural choice: composition over competition. They deliberately kept the ARD specification completely artifact protocol agnostic. That means they built a framework for discovery that places absolutely zero constraints on what actually gets discovered or how it's transported. Because of that, ARD can seamlessly grow to include substrate-level protocols like AGTP without anyone having to do a massive overhaul. You can draw a really clear boundary here. They operate at completely different architectural layers, doing very different jobs. On the left, ARD answers the discovery question. It identifies where capabilities live and ensures you can trust them before you ever connect. Then, on the right, AGTP answers the transport question. It securely carries that connection with all those structural identities baked right into the wire. So ARD helps you find the endpoint, and AGTP securely transports you there. It's a perfect match. Let's move to this and see how this builds in a real-world scenario. Imagine an agent trying to grab an ARD catalog. Step 1. The agent invokes the discover method at an AGTP native location, say agtp/agents.acme.com/catalog. Step 2. Because we're on AGTP, that request inherently carries the agent ID, owner ID, and authority scope right at the wire level. Step 3. The receiving endpoint instantly applies context-aware policy without messing around trying to reconstruct identity from session states. And finally, Step 4. The response returns the exact same ARD catalog manifest you'd normally get over HTTPS, but now it's packed with substrate-level context. It's just so incredibly clean. In fact, this composition is so flawless that formalizing it at the IATF level requires barely any effort. As you can see with this draft binding, it proves just how clean it is. It's really just incremental work, proposing a specific media type for AGTP agents, placing those AGTP:identity URIs straight into ARD's existing trust manifests, and laying out how catalogs are published at substrate native paths. It respects the entire ARD architecture while totally solving the transport problem. Finally, Section 5, the next infrastructure decision, moving beyond the status quo. Let's zoom out for a second and look at the bigger picture. The launch of RAD is a massive, real victory. The industry is effectively agreeing that the discovery layer and trust metadata layers are settling. But the application layer above that, it's fragmenting fast, with protocols like MPC and A2A, and underneath the whole thing, we're all still operating on this implicit, kind of dangerous assumption that everything just runs on HTTP. Well, as we saw with the BadHost vulnerability, that assumption absolutely has to be challenged now. The substrate question is undeniably the next frontier for AI. So I want to leave you with this final, provocative thought. The tech giants have handed us a really brilliant discovery tool in ARD, but the foundation that it runs on? That's the next big choice our field gets to make. Are you going to stick with the human-centric, vulnerable conventions of HTTP? Or are you going to evolve toward a purpose-built agent substrate like AGTP? Basically, what substrate will your agent infrastructure run on tomorrow? Something to think about, for sure. Thanks so much for joining me on this explainer, and keep building the future.